So now that we know
Three different ways to find the x-intercepts of a quadratic function, either by factoring, completing the square, or using a quadratic formula, let's practice graphing quadratic functions. And please make sure you complete your guided notes as we go along. So friendly reminder, I think I include this slide in almost every PowerPoint, but the domain of a function is the set of all possible x values, and the range of a function is the set of all possible y values. So we've got our domain, that's our x's, and our range, that's our y's. And a function is a quadratic function if it is in this form. F of x equals ax squared plus bx plus c. And like I said before, I think at the beginning of this module, that the graph of any quadratic function is a parabola with a vertical axis of symmetry. It's always going to look like a parabola, and it's always going to have a vertical axis of symmetry as long as it's in this form. So our most basic parabola is our squaring function. This would be the function f of x equals x squared. And what it does is it pairs every x value with its perfect square. So when x is -2, I would have -2 squared, which is 4. And we see this on our graph, right? Here's where x is -2, and our output y is a +4. If x is -1, I've got -1 squared, which is 1. This point here. If x is 0, I have 0 squared, which is 0. If x is +1, I have 1 squared, which is 1. And if x is +2, I have 2 squared, which is 4. This is our most basic parabola. This would be like the parent function of parabolas. Its domain is all real numbers. I can plug in any x value and get out a y value. Its range is from 0 to infinity. If we look at our possible y values, my y values don't start until I hit 0, and then they like go up. So it's only from 0 to infinity. Our vertex, as I've said before, is where our graph looks like it's switching from negative slope to positive slope, and it's where our line of symmetry goes through. So in this example, our vertex is 0, 0, and that axis of symmetry is when x equals 0. And it's continuous over its entire domain, meaning I can draw it without picking up my pencil. Now, we've talked about vertical shifts of graphs before when we were working with radical functions. If I had f of x is the square root of x and I wanted to shift that up 2, I'd add 2. Or if I wanted to shift it down 3, I would subtract 3. The same works for parabolas. Isn't that nice? This works for all of them. So if I have a parabola and I add some constant to it, that's going to shift my graph either up, okay, or if I was subtracting it, if I was adding a negative number, it would shift it down. Okay, so here would be like f of x is x squared minus k, right? So its vertex changes, its axis of symmetry remains the same, the domain remains the same. What's going to change is that range. That's what we're going to have to look for because my y values have shifted either up or down. So let's practice graphing some of these. So what I always recommend doing is either envisioning the shift of our graph. Okay, this has been shifted up 3. And that helps me figure out, oh, well, that means I'm still going to have the same axis of symmetry. So here I'm going to pick some of our standard x values. When we plug them in, we'll see how our graph has been shifted. So I've got f of -2 is -2 squared plus 3. That's going to be 7. I've got f of -1. That's -1 squared plus 3. That's 4. F of 0, 0 squared plus 3 is 3. And I hope we notice that there's this pattern of symmetry. We talked about this axis of symmetry. So I'm going to get the same y values when I'm equally away from this axis of symmetry. So as I said, my graph had been shifted up 3. I now have when x is 0, y is 3. When x is 1, y is 4. -1, y is 4. And 2 puts me and negative 2 put me at 7. This is my new graph. I could think of this as my original graph, but every point's been shifted up 3. So this is my parent function. Some things that are important to label when it comes to parabola. My domain, always all real numbers. Don't even need to think about it. My range, this time now goes from 3 to positive infinity. My axis of symmetry is still the same, but my vertex is no longer the origin. My vertex is now when x is 0, y is 3. Those are the 4 things we should be able to label when it comes to graphing our quadratic functions. Let's take a look at this again. I've got x squared minus 5. Let's do this one by graphing our parent function first, and then looking at the shift. So I know this was my parent function because x squared is the simplest parabola and it matches every single one of its x values with its perfect square. Typically 3 points will do you just fine as long as one of them is our vertex. You need to have the vertex. So now I'm going to shift everything down 5. This is shifted down 5. So I'm going to take my vertex and shift it down 1, 2, 3, 4, 5. I'm going to take every point and shift it down 1, 2, 3, 4, 5. I know I've got some symmetry. 1, 2, 3, 4, 5. So visualizing what goes on with these means I don't have to substitute in a whole bunch of x values. So this is my new function. This is f of x is x squared minus 5. My domain, all real numbers. My range, well, now my range starts when x is negative 5 and goes, when y is negative 5 and goes all the way to infinity. So I'm going to have negative 5, and negative 5 is included, so it gets a bracket all the way to infinity. My axis of symmetry, sometimes we just call this our axis, is when x equals 0, and my vertex is now when x is 0, y is negative 5, right? So that's how we're going to deal with graphing functions, shifting them up and down. For horizontal shifts, it's the same as when we were working with radicals. Before, the change would have to be under the radical symbol to shift it right or to shift it left. And it was the opposite of what we thought, right? The same is true here. So now it's got to be within that square because our function is the square, not the square root. So what's going to change is my vertex. If I shift, my vertex is going to change. And my axis of symmetry is going to change as well because our axis of symmetry goes through that vertex. So let's practice shifting some of these parabolas. So here I have f of x equals x plus 3 squared. So this is going to be shifted, not left. Yes, left. It's not going to be right, even though it's positive. It feels like it should be to the right, but it's not. It's going to be shifted to the left. Left 3. So how could I see that if I wanted to substitute in values? Well, I set it equal to the first few values of our parent function. So since f of x is x squared, it's negative 1, 0, 1, 1, 0, 1, right? This would be our little table. I would set it equal to those values. So I get x is negative 4, x is negative 3, and x is negative 2. And I could substitute those values in, right? F of negative 4 gives me negative 4 plus 3 squared, so negative 1 squared, which is 1. F of negative 3 equals negative 3 plus 3 squared, 0 squared, which is 0. And f of negative 2 is negative 2 plus 3 squared, which gives me 1 squared, which is 1. Okay? So here would be our new points. I could find some more. I could see when x is negative 1 and when x is negative 5 and find more points, but you really just need those 3. Notice this is our parent function. But every point is shifted over 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So I didn't necessarily have to find this table of x values. I could have just shifted my parent function. But when we're shifting our parent function, we want to set it equal to the first few x values of our original function, would be the way I would go about it. Let's try this again. I've got x minus 5 squared. This is going to be shifted right 5. So we have our original parent function. I'll do that in blue. And I can label 5 points because it's fine. I know what they are. So here's f of x equals x squared. And I'm going to shift everything to the right 5. 1, 2, 3, 4, 5. This is my new vertex, which we didn't label in the last example, but we'll go back and fix that. When x is 5, y is 0. This is also going to be my new axis of symmetry. When x equals 5, and every single point has been shifted over 5. This would be my new graph. My domain is still all real numbers. My range in this case goes from 0 to infinity. Let's take a look at the example 3 and label the vertex and axis of symmetry and all those lovely things. So my new vertex here for our function in blue is when x is negative 3, y is 0. Our axis of symmetry is when x is negative 3. Our domain, all real numbers, that never changes. And our range in this example goes from 0 to infinity. So those are important things for us to identify as we are solving these functions. So let's describe the shift of these parabolas to make sure that we are on the same page. Take a minute, pause the video, and write down the answers, and then I'll show you the answer key. So our answers are this. If I've got it added outside of the radical, that's going to be shifted vertically 4, so up 4. If I've got it inside the parentheses, that's going to be shifted horizontally negative 4, so left 4. If I've got it outside of the square, it's going to be shifted vertically negative 2, so how about down 2? And if I've got it inside but subtracted, that's going to be shifted horizontally 2, that's going to be right 2. That's how we're going to shift our functions. So I can kind of put this all together once I show you one more thing, and that's graphing a negative quadratic function. So we have our original parent function. I'm going to do that in green. So here's our original function. This is f of x equals x squared. How is that going to change if I put a negative in front? So let's plug in some x values. So if I have f of negative 2, that's negative 2 squared. Negative 2 squared is 4, it's negative 4. If I have f of negative 1, it's negative 1 squared. Well, that's going to give me negative 1. F of 0, that's negative 0 squared, which is just 0. And I'm going to have my symmetry that I have. Well, if we look at this, it's the same as my original parabola, except it flips upside down. This negative sign, this flips our parabola. It makes it sad. The negativity makes it sad. So my domain is still the same. My vertex is still the same. My axis of symmetry is still the same. What changes is my range. My range now doesn't go from 0 to positive infinity. It goes from negative infinity to 0. So a negative in front is going to flip our graph. It's going to flip our graph over the x-axis. So here's bringing it all together. So when I have f of x equals a times x minus h squared plus k, that k is what's going to shift our graph up and down. This h is what shifts our graph left or right. And this a in front can represent a reflection across the x-axis. That's if it's negative. And or a vertical stretch or compression. It's going to change the shape of our graph. Well, what does that look like? Well, if my graph is going to be wider if a is a fraction. So if the absolute value of a is between 0 and 1. So here I have g of x equals 1/2 x squared. Notice how my graph is wider. That's because if I had filled out a table and I substituted in 1, I'd have 1 squared times 1/9. That's just 1/9. So my graph is kind of like pushed down. Instead of being at 1, it'd be at 1/9. And if I put a constant in front that's bigger than 1, we call that a vertical compression or a shrink. See how my graph is narrower? I could write that. Let's be color coordinated, shall we? If I made the same table, 0 stays the same, but now if I have 9 times 1 squared, that's 9. So now I'm at 1, I'm like way up here, right? So we have to know how our vertex has been shifted to figure out our x values we're going to substitute in, and then plug them in if we have a vertical stretch or a shrink to figure out the shape of our graph. So let's bring it all together. I've got f of x equals x plus 3 squared. So this shifts my graph down 4 and left 3. So if I have my original vertex, my cat just jumped into the bed with one of his toys. We're going to see how this goes. But here's my original function. And I'm going to shift every single point down 4. 1, 2, 3, 4. And then to the left 3. 1, 2, 3. There we go. That's my new point. Again, down 3. Left 4. Sorry, down 4, left 3. That puts me here and here. Last, down 4, 1, 2, 3, 4, over 3, 1, 2, 3. Here we go. This is my new graph. There was no vertical stretch or shrink and no shift. My domain is all real numbers. My range is from -4 to infinity. My vertex is when x is -3, y is -4. And my axis of symmetry is x equals -3. Notice here the sign changed because it's left -3. down 4, but this gives me my vertex. My vertex was when x was negative, when y shifted down 3, and I went to the left 3, so it's like x minus a negative 3. This is a hint of things to come. This is my HK. Next, I have negative 2x minus 1 squared plus 4. So this is a little bit different because I've got a vertical compression. I've got a number in front, but I can see how my vertex has been shifted. It's been shifted up 4 and right 1. So if I know where my new vertex is, instead of being at 0, 0, I'm going to go up 4 and right 1. This is my new vertex. When x is 1, y is 4, and that'll help me pick my other x values. So let's do 0 first. If I have f of 0, that's negative 2 times 0 minus 1 squared plus 4. If I have f of 0, that's negative 2 times negative 1 squared plus 4. F of 0 is negative 2 plus 4, which is 2. And that's also going to be the value when x is 2 because of my symmetry. Notice now my parabola is going to be opening down. And that makes sense because there was this negative in front. And it's also growing twice as fast. Whereas before, I would have had like just going up by 1. Now it's flipped and going down 2. Let's find one more value. When f of negative 1, I've got negative 2, negative 1 minus 1 squared plus 4. F of negative 1 is negative 2 times negative 2 squared. F of negative 1 is negative 2 times 4 plus 4. Negative 2 times 4 is negative 8. Negative 8 plus 4 is negative 4. So this is going to be my new value when x is negative 1, y is negative 4. It'll be the same thing when y is 3. So this is my new parabola. My domain, all real numbers. My range, from negative infinity to positive 4. Our axis of symmetry is when x is 1, and my vertex is when x is 1, y is 4.